Today we're going to focus on a fictitious investigation that is sort of loosely based around the 2009 Vancouver Gang War. So first, I'm just going to provide a little bit of background on the Vancouver Gang War. So this particular spree of violence was instigated by the successful seizure of cocaine shipments from Mexican drug cartels by the Mexican army. So as a result of the limited cocaine supply, the price of cocaine skyrocketed in Vancouver, making drug dealing a far more lucrative legal enterprise. So there were several players in the Vancouver drug scene, including the United Nations gang and the independent soldiers, who traditionally acted as dealers for the Hells Angels drug suppliers. But with cocaine trade becoming more lucrative, new players like the Red Scorpions began to encroach on traditional UN territory. The decisive moment came when the Bacon brothers, prominent UN gangsters, left the UN and joined and later took control of the Red Scorpions. Together, the Bacon brothers and Red Scorpions were able to pose a significant threat to UN dominance, causing the eruption of a full-blown war. So that's just a little bit of intro, a little bit of background. So we're going to jump right into ArcGIS Pro Intelligence right off the bat here. So here we are. We can see I've got it in the nice dark mode, and we can see we have our nice tailored and simplified ribbons up at the top. So the first thing I've done is I've just, all those gangs that I quickly mentioned, I've just, sort of digitized their logos and placed roughly where their headquarters are on the map. So this is one, nice way to visualize that particular aspect. But as you'll notice from my intro, there's a lot of, relationship and intrigue happening between these gangs, and it's a little bit difficult to wrap your head around. So, for me, this was a great use for a link chart to sort of figure out, who's working with who and who's at war with whom. So let's do that. Let's go ahead and we'll build a link chart right off the bat here. There's a few ways to do that. The easiest way, though, is probably just to jump up here to our new analysis tab. And then our first button up here is the link chart. So we'll go ahead and open a new link chart. So it creates a nice blank link chart for me, and it, handily tells me to just go add my first entity. If you've worked with link charts before, this is what we would call a node. We just changed the name to entity. So we'll add our first entity. So all I'm going to do is add that gangs layer that I've already turned on in the map. And then I just need to give it a field that, I want to display it based off of. So it's going to be name. And we'll just keep this thing simple and just call the entity gang. So I'll hit OK. And this is going to bring all of those gangs in. And if I have nice symbology in the map, it'll bring that symbology into the link chart for me, which in this case makes it much easier to understand who we're talking about. So now that we have that, you'll notice up on our ribbon that our relationship type button has now been illuminated. That's because we now have an entity to work with. So we can start building some relationships or links. So we'll just link the gang entity to itself, so gang to gang, and we're interested in who's allied with whom, so we'll just call this allies. And then we just need to provide it some key fields, so how we're going to link everything together. So in this case, we'll grab the allied with, and our target entities are going to be the name. So we'll hit OK. And just like that, it's drawn the links on my link chart for me, ready to go. So I can already, start to see who's allied with whom. We'll add one more relationship type, this one for who's rivaled with whom. So we'll grab gang and gang again. We'll call this rivals. And then for our key fields, it's going to be very similar. We're just going to grab rival and then name again. Whoops. Grab name again. There we go. But okay. All right. So now we have our allies and our rivals in here. Now, you're probably looking at this going, well, this isn't very clear, of course, because it's difficult to distinguish between the two sets of lines. So we can come over here into the contents pane. And as Pierre was mentioning, that's also new. So we can come in. We can go into our relationships. And we can come in and look at this particular relationship, allies. And you notice when I select that, my symbology becomes available. So I can open that symbology, and maybe I want to change that to a nice green color. So there we go. So we got our allied in green, and for rivals, we'll make that red. Okay, so already this is a little bit easier to understand, but I'm not too happy with the layout. It's a little bit cluttered. So I can come up here to my ribbon again and go ahead and change that layout. Let's go with organic, see how that looks. Just going to redraw all that, and we got this nice it spreads everything out and we don't have any overlapping lines anymore. So already pretty quickly we can, for example, look at the UN gang and understand their strong relationship with the independent soldiers, and then their, sort of fraught relationship with the Red Scorpions and the Bacon Brothers. We can also see who some of the main suppliers are, of different, cocaine shipments. So that's a very, very basic link chart. And, it really is a good visualization tool, but we're not quite ready to do any sort of link analysis. I think we need some more data. We need to find some questions that we want to ask. So another set of data that I have, and you can see this in the contents pane, is my gang members. So I have information about different gang members. So just going to open up that attribute table. And what we have here is the name of the gang member. If I know it, I don't know the names of all of them. I'll know their gang affiliation. And gang affiliation here is crucial, right? Because this is how we're going to link our gang members to our gangs. We'll do it by the gang name. So that's going to be our linking field. And then the other thing we have here is just some extra information about each one of those gang members if it's available. So, for example, if they have a vehicle associated with them, that's been put into a field, as well as the vehicle's color. And we've also gone through and looked at their ethnicity as well. So what I want to point out here is this particular table is a very good candidate for doing link charting. And that's because it follows good database design principles, and it has everything broken down into its smallest logical components. So instead of having just a description field with all this information in that description field, it's all broken apart. So if we had a description field like that, there'd be a little bit of data cleaning we would need to do to get a very compelling link chart put together. So all I want to do here is just do the same, steps and just go through and add the different entities and build the relationships. Same process I just showed you. So just in the interest of time, we'll just skip ahead here. And so all I've done is I've just added all of those gang members in, and then I've added nodes for ethnicity, I've added nodes for vehicles, and I've added nodes for vehicle color. So we have, the same basic underlying link chart with our gang relationships underneath, but then we have all our different gang members spread out here. So we're getting close here. This is, as you can see, a much more complicated link chart, and potentially we could start doing some link analysis here. But I think I'm going to add a little bit more data in and see what we get. So what I want to be able to do is link my known gang members with some open cases that, that existed in 2009, and see if we can match suspects with known gang members. So unfortunately, that data, it's old, it's from 2009, and all I have is it's in this old school PowerPoint, not very useful, right? So it's, but it's hard for the computer to read, but there's some good information in here. So crucially, you'll see down here that we have, some similar fields such as, the suspect's ethnicity. If there was a vehicle involved in the crime, we've reported that, and also the color of that vehicle. So already you're probably seeing that we're going to be able to take that and add that into the link chart, and then based on those links, we should be able to narrow down some suspects. So I have about 20 of these PowerPoints. Now, I could manually bring them into Pro, but that's pretty tedious, especially, 20 might be doable, but 100 would be kind of unthinkable. So luckily, over here on the Data tab, I have access to LocateXT, which is an extension for Pro, and it allows me to bring in unstructured data. So let's launch LocateXT. So here we are. We're going to get ready to do extract locations. Pretty simple to use. All I need to do is go browse to the folder where I have all those PowerPoints. So there's about 20 PowerPoints in this folder here. So I'll add that. So that's what it's going to go search through. And then I just need to give it an output feature class. So we'll just call this Open Cases 1. And then we're going to do a little bit more tweaking just so that we can get that data into that, nice database design principle and have those smallest logical parts. So we'll jump over here into properties. And this is where the magic really happens. If we go over here to extract attributes, we can extract custom attributes. And we do this by using what's called a gazetteer file. So the gazetteer file basically tells LocateXT what you're interested in pulling out of any type of document. And then based on that, it'll pull that data out and it will put it into a unique field for you. So I've already built that gazetteer for us. Just to save a little bit of time, but let's just go look at it really quickly. They're quite easy to build. So for example, let's look at this case info. So in this particular case, what I'm asking Locate XT to do is go find the keyword case number with a colon. And anytime it comes across that in any one of the documents, what it's going to do is afterwards, it's going to capture a set number of characters after that case number. So that's perfect for something like case number, which should be a standard set of characters. So that's a good way. So it's going to find case number as a keyword, and then it's going to capture a set number of characters and put that into a field for me. Another example here is description. So very similar. It's going to find that description keyword. But this case, of course, description is not going to have a set number of characters. So I have a few options, but I can tell Locate XT, you know what, just capture everything until you hit a stop string. And by a stop string, we usually mean something like a hard return. So if someone hit enter when they were typing, you know, meaning they've moved to the next line, that's when it's going to stop capturing. So a bunch of different options. Those are just two. So we've built that gazetteer, and essentially all we need to do is come up here to extract, and we're just going to change this to 2 because I think I've already used the number 1, and we'll go ahead and extract that. So it's going through, it's reading through 20 PowerPoints, and actually it's already done. So it just read through 20 PowerPoints, and it went and plotted all of that on the map for me. I can also give it custom symbology so that it'll present that symbology right away. And if I open up the attribute table of what we just generated, it's got a lot of fields here about what it was doing and how it did the capture. But crucially at the end here, you'll see it's captured you know, the ethnicity, the vehicle color, and then the case info and description. So just like that, we've been able to take, you know, sort of semi-structured data out of a PowerPoint, get it into ArcGIS Pro, and be able to use it in link charting and link analysis. So let's do that. So we go back here. Again, because it's a demo, I've cheated a little bit, which is fair. I've gone ahead and I've just brought that open case data in, and I've linked it all together because it takes 3 or 4 minutes to build all those relationships up. So we'll go up to here to the diagram again. So now that we've got our sort of, I would say, fairly complete link chart done with all the different data elements we want, we can now start doing some data analysis. So to do that, we can come up here to our link analysis tools. And we can open up and choose what sort of tool we want to run. So today I'm going to focus on paths. Actually, I'm going to focus mostly on neighborhood analysis. We'll do a bit of path. Centrality and clustering, very, very useful tools. They don't necessarily apply to this data set because, as you can see by this link chart, I have lots and lots of links. So everything is sort of clustered together already. This is good if we have you know, lots of data and there's only one connection between each node or 2 connections. Centrality and clustering is really powerful in that sort of case. So let's start with our neighborhood analysis. So the first thing I want to do, this is that PowerPoint we were looking at there, that you know, BC case 2009-0002. So I don't really remember what was going on there, so I can just do a quick neighborhood analysis and just select on that node. And just like that, it's going to pull out, you know, the key things that so the things that are connected to it within one node. So essentially the description of, in this case, the description of the suspect. So we know that this suspect is Caucasian, drives a Ford Explorer, and then that Ford Explorer is green. Now we could probably, you know, start looking at these links and see there's, you know, only a few links to Ford Explorer, so we might be able to dive in that way. But the other thing we could do is just extend our neighborhood analysis out to an additional node. So by doing that, it's now highlighted anything that's basically within 2 nodes of that case. So what we have here is it's highlighted any one of the gang members that either are Caucasian, drive a Ford Explorer, or drive a green car. So it's basically generated a quick suspect list for us. And so we're going to want to go ahead and narrow that down a little bit more, but you can see how quick it is to, you know, take a lot of data and figure out, you know, what is interrelated most closely. So let's see here. Let's look at this Don Lyons. I'm just going to pick him because he's just close in the link chart. Doesn't actually mean he's a close link, but I just want to see what's going on with him. So to do that, I can switch from neighborhood analysis to a compare neighborhoods. And for that, I just need to grab my case. and then I'll grab Don Lyons. And it's basically going to highlight any of the nodes that are within one node of both of those. So what this is telling us is that Don Lyons is Caucasian, and then he drives a Ford Explorer. So, that's pretty compelling stuff. There's, I think, a high probability that, he might have been involved in this. But I'm also noticing here that Jamie Bacon, he also has, looks like he also drives a Ford Explorer. So let's do a quick analysis on him and see what we're going to get. So same process, we'll grab this case, and then we'll grab Jamie Bacon. And you can see here that he actually matches even better. So he's Caucasian, drives a Ford Explorer, and we know his Ford Explorer is green. So we can narrow down on Jamie Bacon and see, if we want to put maybe, more surveillance on him, or see if we can see where, if he's got an alibi for the time that this crime took place. So that's a quick neighborhood analysis. I'm just going to show one quick other analysis. So we'll erase this one. And that's the path analysis. Maybe not as practical here, but for example, if we wanted to know, if we were looking at, for example, Jamie Bacon and maybe this guy up here, Barzan, and we wanted to see, how are they linked together? We could do, for example, a shortest path analysis. So we could select on Jamie Bacon and then select on Barzan. And just like that, it's done a quick path analysis for us, so we can see that they are a minimum of 4 nodes apart from one another, and that they would have to go through basically a gang that's at war with each other. So, if we were to see these two people interacting, we could say that, that's a little strange. They're not very closely associated. So that's just a quick path analysis that we could look at. Okay, let's jump back over to the map now. So here we have the map. I'm just going to turn on the same data again. So here we have this open case data that I ran just prior to this demo. And what we're going to do here is we're going to create another type of chart, which is called a timeline. So to do that, again, we just come up to our analysis tab, and right beside the link chart is timeline. So this is going to allow me to break down all the different cases by the time that they were reported or that they occurred. So to do that, I just add my open case data, and then I'm just going to display it based on the case info, which is, of course, the case number. So we'll hit apply. So just like that, it's generated a nice timeline for us. So we can see, quite a bit of activity happening in January and February of 2009, and then it's sort of petering out, into the spring. But the important thing about this timeline is it works interactively with all the other charts and maps that I've created. So just going to give myself a little bit more screen real estate. So I'm going to go grab our completed link chart, put this on one side, and then we'll just collapse down the contents pane. And we can see now we get a nice view of all the data, so we can view it spatially, we can view it temporally, and we can view it based on attribute relationships. The other thing, too, is if we come up to timeline, it's also got its own ribbon, but we can do a selection. So maybe I'm interested in all the cases that happened in February, and you'll notice it'll select all of those on the map. It will also select them all in the link chart. So it's a very nice way that we can look at our data in multiple different perspectives all at the same time and really get a better understanding of what we're looking at. Okay, so we'll clear that. And now we're going to sort of shift gears a little bit. We're going to move away from this link charting and link analysis and move into the new movement analysis that Pierre was talking to us about. So we're just going to bring my screen back, bring up my contents pane again, and then bring up my catalog. And we'll go ahead and switch here to the movement analysis. Okay, so we're in movement analysis, and what I have here is a series of GPS points. So we were lucky enough to get a court order, for example, and we were able to track, several of the gang members over the course of a day. So what we have here is just the GPS points from all of those gang members over one day. So let's open up that attribute table and see what we got. So we have about 12,000 points, and we can see that each of the GPS points has a member name associated with it so that we can distinguish them. And then crucially, it also has a timestamp. So we're going to need a timestamp to do a lot of this, movement analysis, of course. But of course, if you look at this timestamp, it's in Unix or epoch time, so basically seconds since 1970. which is a great machine-readable format, but pretty difficult for you or I to read, and it's also not really the best design for using tools in ArcGIS Pro. Luckily, we provide a nice tool to do a conversion. I know in past times I've had headaches trying to convert Unix time, so I just wanted to show everyone that it's quite easy to make that change. So to do that, I come up to the Data tab, and we come down here, and there's this handy tool called Convert Time Field. So we'll open that one. Very easy tool to use. All we do is feed it that gang member tracks data, and then we input the time field that we have, which is called time. And then we just need to give it the format of it. And we can just simply tell it that, you know what, that's in Unix. Oops. Unix. And underscore S for Unix seconds. And we're going to output it to a field called time converted. And we're going to call that a date field. So we'll hit run. So that's going to go read through those 12,000 records or so. And you'll see in the attribute table, it just went ahead and added a nice human readable date time for each one of those points. So once that's done, we can now start diving into our analysis. Okay, so the first thing I want to do is sort of make some sense of, what I'm looking at here is just a big cluster of points, not that easy. So what I'm going to do is come back to our data tab here, and we have this handy tool called points to track. So we'll use that. And all we're going to do is give it the input of those gang member tracks. We're going to use that new date time field called time converted that we just created. And then we're going to group it by that member name so that we have a unique track for each one of the members throughout the day. And we'll go ahead and run that. It takes about 30 seconds to run, so I'm just going to skip over it and show you what the output would look like. So here's our output. So we can see we got this nice color-coordinated output that shows us the tracks based on the gang member name. The other thing that's really neat about it is if we open the attribute table, it does a bunch of calculations for us as well, one of them being speed. So it will calculate the distance and the time delta between each and every one of the points, and then we'll output a speed value for you. So that's useful just, if speed's a factor in some of the data you're looking at. So we'll close that guy up. All right, so now looking at this data, there's sort of two main things that stand out to me. One, and I think this stands out the most, is if I come up here to Central City Shopping Center, I can see that, a lot of the tracks lead into this Central City Shopping Center. To me, this sort of screams meeting location or drop point or something. So I'm going to want to investigate that a little further. The other thing that might not be as obvious but does jump out to me is this meeting looks like that happened between Jonathan Bacon and Michael Lee. So they're actually on opposing gangs, and it'd be strange if they met like this. So I would definitely want to know if that was the case. So I just want to run some analysis and see, are these meetings, do they go there at the same time, stuff like that. So to do that, I'm going to come up to my analysis tab, and we'll come down and we'll use this new tool called Find Meeting Locations. So we'll run that. Another fairly simple tool to use, all we do is feed it those gang member tracks. And then we just need to give it the name field, which is, again, the gang member, their name. And then we give it criteria for what we consider a meeting to be. So for me, I'm just going to leave the defaults. And for the defaults, what that means is in my definition of a meeting, I think it happens within a 100-meter area. And that they need to be in the same 100-meter area for a minimum of 10 minutes before I consider that to be a meeting. Of course, depending on your data, you might want to change that, and you're fully able to change that however you see fit. But for me, we'll just leave the defaults. Again, because of the 12,000 points, it takes a little while to run. So, the magic of the demo, I've pre-run that for us. So if we come in here, we can see that it has actually identified this West Oaks Mall as a potential meeting area. If we turn this back on, it aligns up nicely with those points that we had. The other cool thing about the meeting location is, again, if I open the attribute table, we can see that it gives us a meeting duration, so how long they had met for, and it also captures the time. So they started to meet around 11:22, and their meeting ended around 11:48. So fairly short meeting, but it did meet our criteria. So that's really, I think that's very valuable. And we can say, with fair amount of certainty that, Jonathan Bacon and Michael Lee did in fact meet. But also what's interesting is what got left out. So you'll notice that nothing happened here. We did not get a meeting location. So what that means is none of these tracks met that criteria. So they were never in the same area, within the same 100 meters within 10 minutes. But I still want to know what's going on here. So for that, I can use a different tool, and that's this Compare Areas tool. So to do that, I just need one other piece of data. I just need to digitize a quick polygon. So I've already done that. So this polygon, I've just highlighted the shopping center, and I've just given it a name called Central City Shopping Center. So all I need to do is give the gang member tracks. The area is going to be this investigation area. And then our point features, the name field is going to be member name, and then the area name. So that's where I gave it that Central City Shopping Center. Now, I could do an analysis based on location and time. That's probably going to be valuable, but let's leave it at location for today. And we would run that. Again, I've already run that for us. So when it finishes running, we get this fairly boring looking output, which just simply matches our investigation areas polygon. But if we open up the attribute table for compare areas, this is where the interesting information is. So it will create a list of all the different members who visited that, were in that area. And it also does a count of the GPS points within that area. So we get a quick sense of, who spent the most time there. So we can see pretty quickly the different individuals who went there. So to me, this sort of means we're missing something in our information. So either this is considered a drop point, and maybe we want to set up some surveillance, or they're meeting with another individual who we are not aware of. So maybe, again, surveillance would be a good idea to figure out what's actually happening in this parking lot. All right, so that's basically the conclusion of my analysis. But I just want to say that, all of this work that we do in Pro Intelligence is, of course, it can, work with the rest of the platform. So if we come back to my story map here and scroll down, we can see that link chart, that very basic one anyways that I created, we can export that as a PNG. They can also be exported as GraphML and XPS, I believe, which are two different formats. So potentially you could be able to bring those into something like I2. We can also, any of those maps that we created and any of that data that we captured using LocateXT, we can bring that right up into the web and share it as part of our briefing tool. And then, of course, any of that movement analysis, all of that data can be converted into feature services, and we can host it either on ArcGIS Online or Portal for ArcGIS.